solving equations using inverse operations. When I'm isolating my variable using inverse or opposite operations, I need to do this in the reverse order of operations. So whereas my order of operations is according to PEMDAS, when I'm solving, I will typically add or subtract and then multiply or divide. And that's exactly what I'm going to do in this first example. 2x minus 4 equals 6. For this equation, the first inverse operation will be to add 4 to both sides of my equation. That is the inverse operation of subtracting 4. 2x minus 4 plus 4 leaves me with 2x, and then 6 plus 4 is 10. My second inverse operation is to undo 2 times x, or 2x, by dividing both sides of my equation by 2. 2x divided by 2 is x, and 10 divided by 2 is 5. That means x equals 5 is my solution to this equation. I'd like to take a moment to talk about a trick that some students are taught. So some students are taught to move a term from one side of the equal sign to the other, just in this case making that minus 4 a plus 4. This is a trick that is not allowed in algebra. So this is not acceptable work. This is magic. Why did I get to magically move that 4 to the other side? And why did it become positive? What is considered acceptable work and appropriate justification is to use inverse operations. So if you're in this habit, please erase it from your memory and get in the habit of using inverse operations to solve. Now the next thing I want to look at is this second example, 2 times x minus 4 equals 6. Notice that these two equations are really, really similar. In both equations, I'm multiplying by 2 and I'm subtracting 4. But the solution of 5 is certainly not the solution to the second equation. 5 minus 4 is 1, and 2 times 1 is not 6. I can use this flow chart to understand why I'm going to solve these really similar equations differently. The flow chart traces through the order of operations and the reverse order used for inverse operations, and this work is never required, but it might be useful for you to understand these different examples. So in the top of the flowchart, I'm going to trace through what's happening to x in my equation. So according to my normal order of operations, what's happening to x is I first multiply x by 2. Next, I subtract 4 from 2x. So according to PEMDAS, x times 2 minus 4, and that gives me 6. When I need to figure out what x is, I need to work backwards. So I'm using inverse operations in the opposite of my order of operations. So first, I use my inverse operation of subtracting 4 by adding 4. 6 plus 4 is 10. And then I perform my inverse operation to undo multiplying by 2, so I divide by 2. That gives me my solution of 5. Now why is that different in this second example? In this second example, if I think through my PEMDAS order of operations, the first thing that's happening to x is what's inside this parentheses. I'm subtracting 4. The next thing that's happening is I'm multiplying x minus 4 times 2. That means when I solve in my reverse order, I don't first add 4. Now the first thing I do is undo that times 2 by dividing by 2. My second inverse operation is to add 4. So notice, same operations, just in a different order, and so my inverse operations occur in a different order. If you want to think about this through the lens of PEMDAS, what's happening in this second example is I have a set of parentheses. That means I do what's inside the parentheses first, and then I multiply. And so when I'm working backwards, I divide, and then I undo what's happening inside the parentheses. So let's go ahead and solve this equation algebraically. Since I have x minus 4 times 2, the first thing I do when I'm solving in reverse order is I divide by 2. So I divide both sides of my equation by 2. 2 times x minus 4 divided by 2 leaves me just with x minus 4. 6 divided by 2 is 3. My second inverse operation is to add 4 to both sides of my equation. That's the inverse of subtracting 4. X minus 4 plus 4 is x, and then 3 plus 4 is 7. X equals 7 is my solution to the second equation. 7 minus 4 is 3, and 3 times 2 is 6. To recap, in both equations, I multiplied x by 2 and I subtracted 4. However, this occurred in a different order. Here, times 2 first, then minus 4. Here, minus 4 first, and then times 2. Therefore, when I'm solving in reverse order of operations, in my first example, I added and then divided, and in my second, I divided and then added. Please notice this is just one strategy I could use for this particular equation. I could have used the distributive property, and that strategy is totally fine. Just here we're solving using a different strategy, thinking through our order of operations.